in here.
Hi, I'm Amy Nguyen, and this is the Chemistry Corner. Today we will be observing what happens when you put dry ice in a water bottle. Oh, hello. I didn't see you there. You must be here for the experiment. Before we begin, you must know that the most important part of an experiment is safety, since we will be handling solid carbon dioxide, otherwise known as dry ice, which is at a temperature of negative 12 degrees Celsius, colder than the freezing point of water. It can burn your hands, so you need something to handle it with, such as tongs or gloves, but these gloves alone are not thick enough. You need thicker gloves, so it's better just to use tongs. Also, a lab coat is necessary to protect yourself, and we have these face masks to cover your eyes, or you can just use goggles. Also, you need to tie up your hair away from your face and make sure there are no loose articles of clothing on you.
In this context, there's no disrespect, so when I bust my rhyme, you break your necks.
Along with the safety materials that were discussed earlier, a couple more things you'll need for this experiment include dry ice, which you can get from your local Albertsons, looks something like this, a mallet to break the dry ice, along with a 500 milliliter bottle of water. And make sure that when you fill up the water, you leave about 1 inch to 1.5 inches of space for the dry ice.
Lose the inhibition, follow your intuition, free your inner soul and break away from tradition. Cause when we be out, girl, it's fully we that. You wouldn't believe how we wow shit out. We burn it till it's burned out, turn it till it's turned out. Act up from northwest, east side. Everybody, let's get into it. Get stoked, get it started, get it started, get it started.
Wow, wasn't that cool? Let's see it again. Look at the bottle now. Look what happened to the bottle. But what caused the bottle to explode? Was it a result of temperature change? The time of day? Let's go to the lab and find out. Hi, I'm Amy Nguyen, and I'm here in the lab with Dr. Armand, chemistry specialist. Honors chemistry specialist. Dr. Armand, could you tell us what exactly made the water bottle explode?
Well, Amy, when ice reacts with liquid H2O, it produces a gaseous precipitate. Molecules in a gas move with elastic energy, meaning that they move in a straight line until they collide with another particle, in this case, the bottle, which creates pressure. As precipitate increases due to the reaction, according to Boyle's law, the decrease in volume increases the pressure, and as we seal off the water bottle, confining the volume, the gaseous precipitate can no longer escape, creating more pressure inside the bottle. At a certain point, when the volume can no longer expand to satisfy equilibrium between pressure and volume, the massive buildup of the pressure will result with the bottle exploding to alleviate pressure.
Well, Dr. Armand, that really is fascinating. I heard you mention something about a Boyle's law. Could you explain to me what that is?
Well, Amy, Boyle's law is a theory which represents the relationship between pressure and volume. Boyle discovered that pressure and volume are inversely related, meaning that when pressure is increased, volume must decrease.
I also heard you mention the word equilibrium. What is equilibrium?
Equilibrium is simply the balance between two opposing forces, in this case, pressure and volume.
Well, wowee, wasn't that fun?
Get it started.